Hello everyone, this is Udit again from Textbook, bringing you another session covering data engineering Q&A. And in today's session, we're going to do some hands-on coding on AWS Glue. So in the previous session, we did talk about what is AWS Glue and what is dynamic data frame in AWS Glue. And today we're going to see some examples how the dynamic frame looks like, how the transformation looks like over here, and how we can convert a dynamic frame into data frame. So without further ado, I'm going to start off with my brief introduction. I have been working in data engineering domain for almost 9 years with various projects and involved in creating data pipelines for several clients. I also train candidates in this field to help them build an interview-ready profile with our comprehensive course covering all the necessary topics of data engineering. So in the previous session, we did talk about AWS Glue, what is Glue ETL, and what are the features of dynamic frames and how it is different from DataFrame. So I'm not going to waste too much of time over here. This is going to be absolutely a practical session, a lab. So not much of theory will be covered. So let me just head back to the AWS console. Now you might have seen this over and over many times. So I have to go to AWS Glue service over from here. So either I can just pick it from the recently visited tab or I can search it over here. So since I have used it very recently, so I'm gonna just click on this one, the Glue service, and over here I will be clicking on the ETL jobs. So once you click on the ETL jobs, you will see so there are three different categories. One is the visual ETL, where you can simply orchestrate an ETL script or pipeline using some drop downs or using some visual graphs. But that is something which is not used very often in real world project. The second one is a notebook where you can create an interactive session to play with the data that is in either S3 or the Glue data catalog, and you can apply all the transformations, all the code logic, and see the result in no time. Third one is the script editor, where you can upload your own customized script and schedule the jobs as and when you want to run it. So for this example or for this session, I'm gonna be using the notebook. So I already have prepared one notebook that is known as the test NV. So I'm going to start this one. So it takes a bit of while to start it. Okay, so now it is starting. Yeah. So by default, whenever you create a notebook or whenever you start a notebook, you'll see these packages are like automatically, the import statements are already there populated. You don't have to do anything. Okay. So there are some basic things like for running any Spark job, right? You have to use the Spark session or the Spark context, and you have to import those relevant libraries or the packages. So similarly for Glue, it is the Glue context. So Glue context is kind of like the entry point to create the dynamic frame. So we will be creating the dynamic frame over here at the beginning, and then we will convert it to data frame. Okay. So to create a dynamic frame, first is you have to create a Spark context, and then you have to create a Glue context using that Spark context. So the Glue context class will be like a wrapper class, which will be wrapping the Spark context, and then you have to create a job using the Glue context. So once the job is created, then you can start create the dynamic frame. Okay, so first we have to run this cell in order to start the Glue context and create a job. So it is showing waiting for session. So once the session is ready up and running, then you'll see the session is created. So let us just wait for it. All right, now the session has been created. So the next step is we have to create a dynamic frame, right? So there are two ways we can create a dynamic frame. One is using the catalog. Second is reading data directly from the S. For this one, we will be reading the data from the catalog. And when I say catalog, it is the Glue data catalog. So whenever we see in the Athena that the tables that are available for us, so basically those tables are mapped into our Glue data catalog in a way that we can get the required metadata information from there. Okay, so by default you see this method, right? The from catalog. So Glue context is you're already creating over here, right? And then you have to call in the create dynamic frame method or the instance, and then from there the from catalog function or the method that will take two arguments, that is the database name and the table name. So to get the database name, to get the what are the database and the tables available for me, I'm gonna head over to Athena. So let me open it in a new tab. Okay, So this is the database that is present for me, that is data underscore hub, and I have four tables under it. So I'm going to be using the EV population data ORC. So let me just copy this one. And the database name over here is data hub. Okay, I'm going to place them, and then I'm going to create the dynamic frame, and I will pin the schema. I will try to look at how the schema looks like, and also I will show the data as well. So I'm going to take only the first five records. So I'm going to put show 5 and then run the cell. Okay, so the cell has been run. So you can see the schema how it looks like. So it has 1, 2, 3, 4, 5, 6 columns: the county, city, model, make, electric, range, and utility. And similarly, I mean, just below the schema, you can see how the data looks like. So you might have noticed that over here it is being shown as a JSON or a dictionary format. It's not like a tabular format. I mean, the way we are used to see when we are working with the Spark jobs or the Spark data frames. So yeah, because so that's the specialty of dynamic frame. So it will create a struct, and that's how it looks like. So if you want to convert it to a data frame, you can just use the toDF method and just call in the df.show, and yeah, there it is. So it's just the same data, but now it is present in a tabular format. I mean, the way it looks like when you run an SQL query. So I'm going to convert this to a data frame later on, but I'm going to do some more operations on the dynamic frame, because this is something that is new to us, and this is something that we want to learn, right? So how things are different over here. So first, let me just apply some of the transformations, some of the basic transformations that we can do. So let me just try to select some of the fields over here. And if you remember, while working with the Spark data frame, it was the only the select method, right? But over here, there is select fields. So under the select fields, you have to create a list. You have to prepare a list and then pass in the column name that you want. So suppose for this one, I want county and model year and the make, okay, the company basically. And I want to see them only. So let's see whether it works or not. Okay, here it is. So now instead of like all of them, only 3 fields are being shown. So this is how the select fields work. So let me just try to rename a field. Okay, so how would I do it? Suppose the model year, I want to convert it to make year. So over there it was for Spark data frame, it was with column name. So but now I have to use the method called rename field, and this is the column that I want to change. So I'm gonna omit all of this. Is the column name, and the new column name that I want to put in is say make year. I mean, this is the year when that particular model was made. Okay. So this should work. Let me run it. Yeah. Okay. So now you can see over here the last column that was model year. Now it is changed to make year. Okay. So it is not the last one. If you compare it with this one, so whenever you rename a field, it it goes absolutely at the end, right? So if you see over here, county, city, everything stays the same, but the model year has been pushed to at the end because I have changed the name to make year. Okay, so this is another one. Let me show you one more thing, that is the filter. So this is pretty different, and it's way more tedious, should I say? Because suppose if I want to do a filter based on the Spark data operation, but how would I do it? I will simply say, and I want to say, I want to only get the data or see the result for which the make of the company is Toyota. So what will I do? I will simply say make column equals to Toyota, right? So this would show me. I mean, this would work me. This would work in case if I was working with the Spark data, but this won't. Let me just try to run it. Okay, call is not defined, right? So even if I try from PySpark dot SQL functions import star, could not serialize object type, I cannot pickle thread or lock object. So basically this is not working. So how do we filter based upon the dynamic frame? So there is a filter class. So how the filter class works is that you have to use the filter like this. So this is a class, not a method, and then you have to give the frame name. So either you can give frame equals to, or you can simply just write the frame name. I'm gonna be using the frame equals to, and then my frame is DYF. That is the dynamic frame. And just look at it. This is how things get a bit complicated. So now I have to put a filter condition in a way how I used to put it in the raw Python lambda function, right? So suppose I want to only fetch out the results that is having Toyota. So I have to put it in a way. So lambda, I have to enclose this in a bracket, I guess. Lambda x, where x is the row, and for each row the make should be Toyota, and I have to pass it to another data frame. Sorry, not a data frame, another dynamic frame, so DYF2, and then let me just do DYF2 dot show. Okay. Okay, not filter, actually it's filter dot apply. There we go. So now if you look at the make, only the Toyota ones are coming over here, right? So this is how the filter works. It's not pretty straightforward for the dynamic frames. Now let me try some other case. Now the DYF2 is there, right? It has only the Toyota. Suppose I want to do some casting or column manipulation. Okay, so suppose this model year column, right? So it's still model year, it's not make year. I want to change this name to model year, and also I want to convert this into string. So how do I do that? I will simply call in, there's another class that is applyMapping. So I will call the applyMapping method, and then I will have to put the column manipulation accordingly. So, so this is the model year. That is the column that I want to change. Now this model year is having the integer, integer as the data type, and I want to change the column name from model year to week year, and then I want to also change the data type to string instead of int. Okay, so if I call this, let's see just what happens. Okay, so you can see the model has been changed to make here, and accordingly these numbers are quoted. So basically it has been converted to string. But you see that all the other columns are gone, right? What if you want all the other columns as well, and you only want the model here to be changed and make here? So you have to do it in a different way. So how can I do it? So there's another class called resolveChoice. I think this is something that I talked about while going over the dynamic frame. So resolveChoice is something that you can change, or you can cast a column to another column, another data type, or also if there is any ambiguity, suppose one column has more than one data type which is not supported by the Spark data frame, but this works well with the dynamic frame, you can, there are like make calls or make struct to create different columns or create different dictionaries, so to speak. Okay, so in order to apply that, so I'm going to be calling the resolve. So let me just call the resolve choice method, and then I have to put the specs. The specs means the specification is I want the model here, and I want this cast to be string. Right. So let's see how it looks like. Okay, invalid type name string. Something is off. Okay, I think there was one extra space, that's why it was showing. So now it's the same thing. The model here has been converted to string, and I can see all the other columns are right here. So is this a win-win situation? No, because if you remember when I was doing the apply mapping, then it was not model here, it was make here. So if I have to do that one step of more manipulation, I have to call in the rename field again. Okay, if you remember, this is something that I showed right after the select field. So I'm gonna call in the rename field. The model here is there. Right, okay. I want this as make. Now everything looks perfect. Okay, so I have the make here as instead of model here, and I have the column value string. Now, very interesting. If you see for the previous case when I was using the DynamicFrame, the rename field was pushing my column at the end, but now it is not. So this is pretty interesting. And when I was talking about resolveChoice in the previous session, so there were different other features as well, right? I can either cast it or I can use something as known as the make calls or make struct. So how do they look like? So basically, if I'm picking this model here column and if I try to use make calls, let me just first remove this rename field because I don't have to rename this way. Just see the difference. If I use the make calls, now you can see this model here. So I'm applying this on the model years. Okay, so had there been any different other data types, in that case, it would have shown model year underscore data type. Suppose if there were like integer as well as string, in that case, it would have shown model year int and model year string. But since that model year, none of the column has a model year which is string, because I am now not casting it, I'm just simply creating two separate columns. So that's why it's not showing it. So similarly, if I do a struct, in that case, I can only see one portion of it. That is the integer part and not the string part or any other data type for that matter. So you can see the model year integer is only there. Had there been any other, in that case, integer 2012 and then string something else. I mean, obviously not for this one because integer is 2012. But suppose there was another column instead of any number, there was string. So it would have shown model year, then dictionary, string, and the value. Okay, so that's how it basically shows. And these are the basic transformations that we usually do using the DynamicFrame. And anytime, as I have shown you, right, you can convert it into DataFrame. So once your DataFrame is there, you can just do a with column rename. And I'm gonna just do model here. So this is plain and simple Spark transformation, right? It has nothing to do with DynamicFrame. So let me just do this. Okay, so now it is working now. Okay, model here is making make here because now I have converted to a data frame. So what I'm gonna do first, let me just create one more level up. So this is my data DYF2. Okay, let me just show it. And I'm gonna write this data frame to S3 now. Okay, I'm sorry. Too many typos. All right, so I have created this data frame. This is not data frame, a dynamic frame. So what I'm going to do, I'm going to write this dyf2 into an S3 bucket, and along with that, I'm going to create an Athena table, or I'm going to update the Glue data catalog accordingly. So these are some by default cells that comes in. I don't need to use them. I'm going to just delete them. So okay, so this is another by default method that you will see every time is there whenever you're opening the notebook. So I'm going to use this one, that is the get sync. So what this get sync will do, it will simply get the S3 bucket path or the S3 URL where you are going to write the data, and also you will see this behavior, right? Update in database. So update in database as in whatever the catalog that you're using, the catalog database name and the catalog table name, those will be updated with the metadata meta store information as well. So I'm going to use my bucket over here. Let me just go to the S3. Let's see if there's any bucket available for me. Okay, so I'm gonna use this dummy bucket X, and I'm gonna use this folder. So I see there are a lot of things already written, so I'm gonna delete all this. Folders hidden, folder will be deleted. Okay, so let me just delete all this because I'm anyway gonna be writing them, right? So this folder is now empty. Let me just the population data. Okay, the folder itself has been deleted. So let me just copy the bucket name, and I'm gonna put the folder name as the population output. Okay. So I'm gonna put the table name over here. That is the by which name the table should be created in Athena, and on which database. So I'm gonna use data underscore hub. That is the database that I'm using. Okay, so the rest. Let me just use a partition key as well. I'm gonna be using the make here as the partition column. Compression is snappy, everything else is fine. I'm gonna be using the bucket format. So let me, okay, so this is the dynamic frame that I have to write. So this is DYF2, right? This is the one DIF2 that I just created. I'm gonna write this data into the S3 bucket and also update the metadata in the catalog, the glue data catalog. Let me just run it now. Okay, so I believe it is already run. Now let me go to the S3 bucket first. Yeah, there it is. EV population output. The folder is created, and over here, all regarding for individual make here, all the partition has been created. And if I click on one partition, you can see the snappy bucket file is there. Now let me go back to the Athena, and if I refresh it, I'll see the EV population data ORC table being created here based upon, I mean, that is pointing to the data that is here in this S3 bucket location, right? So this is a partition data. So if I try to see the show partitions, I mean, if I try to see the partitions in this table, okay, I sorry, down to EV population output more data. All right, so there you see these are the partition columns that are present, right? And accordingly, all these folders have been created. All these four partition folders created. So if I try to do a select star from here, I can see the data in Athena console as well. Limit. Okay, so now the data is here, and you will see only the Toyota ones will be coming here. because obviously when I created the DynamicFrame 2, that included only the Toyota ones, right? That's the filter that I'm applying to have the make as the Toyota. So this is pretty much it about the AWS Glue transformations and how we basically create a script. So if I just combine all these things into one single Python module and then run it as a script, that also works. I'm going to show you in the next session how we can automate a script using AWS Glue. We can simply schedule it, and also we can put some Lambda triggers as well. So as and when the data resides in S3, we can run the script over there. So make sure whenever you're using the notebook or any services for that matter, you have to stop it. Okay, once it is done, you just simply terminate each and every service before logging on, because otherwise it will be big. So in Athena, whenever I run a query, there will be some cost associated, right? So I'm not running any more query, and simply an S3 bucket also. I'm not uploading any more folders. So I'm done over here pretty much. So I'm gonna just simply get out of here, log out of it, and all the services are now down. So this is pretty much it from this session. If you need more clarity, if you have some more concern regarding our course, just reach out to TechSpot. We will help you regarding the course and the all the topics that will be covered. Uh, we will help you with Apache Spark, Hadoop, AWS with hands-on coding and real-world project, and at the end, we will build your CV to ensure that your profile is absolutely ready to get into any industry. Okay, so just reach out to us in case of any help. See you on the next session. Bye bye.
Contact us for the free job assistance. We will help you to get the IT job. Please like, subscribe, and share the channel for more regular updates from TechSpoke.